Alright, class, today we're going to talk about using trigonometry to solve for right triangles. Your objective today is you will be able to solve right triangles using trigonometric ratios. First, just review. Yesterday we derived the Pythagorean theorem using similarity in right triangles. Today what I want you to do, the challenge is I want you to derive the Pythagorean theorem using the diagram on the next slide. So follow these steps, the first step, the second step, and the third step. And then you see if you can derive the Pythagorean theorem. If you show me your work, you will show me your work tomorrow. You'll receive 10 points for trying and 0 for nothing. Basically, what I want you to do is find the area of the large square. So it's going to be a plus b times a plus b, and then set that equal to the sum of all its pieces. So there's 4 congruent triangles here and 1 smaller square in the middle. And then set the two equations equal to each other and see if you can see if you can solve for the Pythagorean theorem. All right, today we're talking about trigonometric ratios. There are 3 trigonometric ratios in a right triangle. The ratios have to do with relationships of the 3 sides of a right triangle from the perspective of one of the 2 acute angles. Remember, every right triangle has a 90-degree angle, and the other 2 angles are acute angles. That means they're each less than 90 degrees because they both have to add up to 90 degrees in order to be a right triangle. So from the perspective of this angle B, the side opposite angle B, we call that the opposite side. The side next to angle B, we call that adjacent. And then the side opposite the right angle, we always call that hypotenuse. The hypotenuse always stays the same because it's always the side opposite the 90-degree angle. See here, from the perspective of angle C, the hypotenuse stays the same. But the opposite side is this side now because it's opposite angle C, and this side is adjacent. We think of adjacent, think of next to. Alright, so first ratio is called a sine ratio. A sine ratio is the length of the opposite side divided by the length of the hypotenuse. So for instance, for sine B is the length of this side, opposite, which is B, divided by A, hence B over A. From this perspective, from sine C, angle C, we have C, opposite side of C, over A. So if this measure here was 60 degrees, and then here we have the given length, so A is 6, and B is 5.2, and C is 3, then what is sine of B? So the way we write that, we say sine of B, which is sine of 60 degrees, is equal to the opposite, 5.2, because we have that here, if B is equal to 5.2, divided by the length of a hypotenuse, which we said is 6, so 5.2 over 6. So this is how you would write your equation. Sine 60 equals 5.2 over 6. Now, since B is 60 degrees, that means this angle has to be 30 degrees because both these angles have to add up to 90 degrees since this is a right angle, a right triangle. So sine of 30 degrees is equal to opposite over hypotenuse. Here C is 3 and A is 6, so we have 3 over 6, which reduces to 1/2. Okay, so go ahead and take some time and see if you can write the sine of angle Z. Follow my hint here, okay, and see if you could write the sine of angle Y. Remember, I will be checking your work to make sure that you're watching this video. Okay, for cosine ratio is adjacent, the side adjacent to the angle divided by the hypotenuse. Again, the hypotenuse is always a length opposite the right angle. So cosine of B is adjacent, C, which is next to angle B, divided by the hypotenuse, A, so C over A. And then this side, angle C, the adjacent side is B, so we have B over A. And then again, you can follow example here. If angle B was 60 degrees and A is 6 and B is 5.2 and C is 3, then we would write that as cosine of 6 degrees is equal to C over A, which is 3 over 6, is 1/2. And the same thing here. This side, cosine 30, we would write that as B over A, which is 5.2 over 6, and that's what we have here. Okay, same thing with the same triangle. I want you to write the cosine of angle Z and the cosine of angle Y. So again, angle of Z here, adjacent is this length, hypotenuse is the long length. So it'll be 1.8 over 5.3. Okay, and then remember angle Y you got to figure that out, knowing that the two acute angles add up to 90 degrees. Okay, then next we have the tangent ratio. The tangent ratio is opposite side of the angle, the length of the opposite side divided by the adjacent side. So tangent B from this side would be opposite side B over its adjacent side C. So here we have B over C. And then the tangent of C would be C over B. Since this is the opposite side, this is the adjacent side to angle C. Okay, then again I have the example. If this is 60 degrees, if B is 60 degrees, and we have the same length as before, then we write that as B over C, which is 5.2 over 3. So tangent 60 is equal to 5.2 over 3. And same thing here, if this is 60 degrees and this is 30 degrees, this must be 30 degrees. So tangent of 30 degrees is the length of the opposite side divided by its adjacent side. So it's 3 divided by 5.2. Okay, again, using the same triangle, I want you to write the tangent of angle Z and the tangent of angle Y. Okay, now using what we now know about these ratios, you could use those ratios to find the missing sides of right triangles, using the ratios. So here, let's say you're given an angle 75 degrees. You have the adjacent side, and it's saying, what's the height of this triangle? Well, the first thing you want to do is you want to figure out what's the relationship between this side and this side to this given angle. Well, you should know that H is the opposite side of angle 75, and 3 is the adjacent side to 75 degrees. So this question here, which trigonometric ratio uses the length opposite and the length adjacent of an angle? Well, you know that's tangent ratio. So the tangent ratio, we can write that as tan 75 is equal to H over 3. This is opposite over adjacent. And then we solve for H. We multiply both sides by 3, and we get 3 times tan 75 equal H. In your calculator, you're going to type this in your calculator 3 times tan 75, and you'll get H is about 11.2. Okay, since now that you know H is 11.2, you could also solve for X. You could also find the hypotenuse using cosine or sine. So again, if you're using this angle as your starting point, as your reference point, then you know that the side opposite is 11.2 and the hypotenuse is X. So again, you want to figure out which trigonometric ratio includes both the opposite length and the hypotenuse, and you know that should be sine. So then you write that as sine 75 is equal to opposite over hypotenuse. Opposite is 11.2, hypotenuse is X. Now here, if you remember, this is a proportion, by the way. These are proportions. This is sine 75 over 1 is equal to another ratio, 11.2 over X. And using one of the properties, I could flip both ratios, and then I multiply both sides by 11.2, and I get X is equal to 11.2 divided by sine 75. So you're going to type this number in your calculator, and you'll get that X is equal to approximately 11.6. And you could also use cosine as well. You could use cosine ratio to solve for X, and you should get the same answer. Okay, so what I want you to do now is I want you to practice this yourself. You're going to click on this link here. This link will take you to a worksheet. Do the best you can. I'll check your math notebook to see if you took notes and if you did the problems mentioned in this lesson. We'll go over this worksheet and more examples in class tomorrow.